So previously we have seen properties of a digital signature, that is pre-image resistance, secondary image resistance, and the collision resistance. Already we have come across this pre-image resistance here. Pre-image resistance is already discussed, and let us go ahead with remaining parts, and let us introduce what is digital signature, how digital signature could be worked out here. Okay, motivation for digital signature. So this concept was already discussed with you. And then second pre-image resistance, in the sense, so second pre-image resistance could be always ensure you that message cannot be easily forged. Message cannot be easily operated for forge here. So here you need to understand one particular point. Throughout this particular unit, we would like to consider message will also be open for everybody. Message will also be open for even the intruder can also see what kind of message which has been transmitted over insecure channel. It could be seen everybody. But the problem is, I mean, the security measure is including message. We have been generated one digital signature, and that digital signature will be embodied or merged with a message and can be sent to the recipient. Okay, during this particular point, what exactly been happened here? Okay, already we have seen some kind of issues here. Second pre-image resistance will be always ensure you that second pre-image, in the sense. So let us consider Alice and Bob, two parties are there with us. So Bob is trying to communicate with Alice at this particular point. Bob has prepared one particular signature, digital signature, whatever the signature it might be. And a message will be taken for this particular message. He has prepared some signature, and he will send this particular message and the signal. These two will be combined together. This is a message, and this is the hashing, otherwise the digital signature. This will be sent to Alice here. Okay, and here Alice will be, after receiving this one, not only Alice, in the middle, people also be received. People in the sense, intruder or some X or some Y or Z, many number of people will be received. But here we need to understand, so this particular, soon after receiving this particular message by the Alice, so then she will be again calculates, so hashing. Again calculate, this is actually message and this is the hashing here, hash of that particular message here. So she will calculate again hashing for this particular thing, that is H prime of message, and she will compare these two, whether this one and this one will be same or not. If these two will be same, whatever the message she has received, that is correct. If these two could not be same, that could be so considered as message will be somewhat forged or somewhat manipulated. Okay, something like that. So while doing this particular kind of so calculation of, sorry, this one H of H prime of M, while doing this particular calculation, it should be ensured that it could not be forged. Okay, so that is the point we'd like to understand here. And so Alice also be created, so some message digest, that is MD, and will be calculated. Already I have discussed with you just before. So another message will be hashes, and it could be same. It could be identify whether exactly same digest or not. If this could be there, then we would consider second pre-image resistance will be gets calculated. So that is what. Then collision. Let us consider Alice and Bob only. Bob has message 1 and message 2, 2 or message 3, and so on and so forth. Several different kinds of messages, not exactly same. Several different kinds of messages will be there. And he wants to communicate this message with Alice first, so that he may be prepared some kind of hash of this one and can be sent to the Alice here. So here, whatever the hash which could be obtained for this particular message 1 could not be equal to this particular second message, could not be equal to third message, could not be equal to message N. Okay, so this is individual message, and this is another individual message, this is another individual message, and so on and so forth. if you wanted to identify hashing of different kinds of messages, so these message hashings could not be the same. Okay, the signatures could not be the same. Then that is called as a collision resistance. Collision resistance is always identifies that. So if two hashes will be taken for two different kinds of messages, hash values could not be the same. If will be same, collision resistance will be fail. If it is not equal to same, then collision resistance will be there here. So that is the point we would like to understand regarding to this particular thing here. The intruder cannot find the two messages that hash are the same digest. Okay, so for two different kinds of messages, the same kind of hash could not be identified, or signature could not be identified. So that could be considered as collision resistance. So with this particular thing, with respect to these 3 points, we'd like to remember something. Hash functions are always, already I have told you, it is one-way file. This is one-way function. One-way function in the sense, you may be just prepared. You could not get back that particular data from the hash. Normally, this hash will be used for passwords, and this password will be stored by the operating system. Okay, instead of password, it has been stored. And as and when, so hash will be created by the user. Obviously, it could be checked by using the hash which was prepared by the user while he is supposed to enter into system or something like that. Obviously, it could not be so retrievable. So therefore, your passwords will be very much safe. Okay. Simply speaking, because of this particular reason, because of one-wayness, so hashes are very powerful when compared to all other security measures. Okay. And then this can be used for so intrusion detection. If anybody is entered into, other than the trusted principles, any other people are being entered into the system or during that particular so communication channel, then it could be gets identified by using hashes, because everybody has their own hash, and if any other hash will be entered, obviously it could be identified. So malicious will be taken into consideration. And virus also be so considered here. If you download any kind of software, so that software is embedded with certain MD5 or SHA or RSA, something like that. Some hash will be gets included out there. So based on that, you could identify whether virus or malware or any other things will be there with you in our software. For these two reasons, so actually hashes are supposed to be used. Okay. So this is what about simple introduction regarding to your hashing. Now let us enter how digital signature will be gets evaluated. For example, so far we have seen public key cryptography. Public key cryptography has taken into consideration, and then private key cryptography also be. So this is a PU, public key cryptography. This is private key cryptography, also seen by us in our previous sessions. Public cryptography will be take huge blocks. The block size will be approximately so 2048 bits, 2048 bits. That is so. Otherwise, sometimes it could also be taken 30. So 72 bits also be taken, whether it is 2 kilobytes or it is 3 kilobytes, something like this. Up to this particular thing, it has been taken into consideration. If your message will be more than this one, if your message will be, for example, your application will be, otherwise your public key cryptographic applications will be get satisfied. So 2048 bit pattern. For example, if you consider like this, I do have 1 MB with me. So 1 megabyte is there with me. Then you may be having huge number of blocks you have to prepare for. So input size will be, each and every block will be having 2048, 2 kilobytes, 2 kilobytes, 2 kilobytes, and so on and so forth. You may be have a n number of 2 kilobytes, which could be satisfies up to 1 MB. Okay. So for our computational purpose, let me consider. So I do have so 10 kilobytes of data will be there with me. So how many times you maybe gets operate your public key or private key cryptography as far as this particular point here in the sense. So every block size will be 2048. So totally, so 5 times RSA or any other Raven system or any other cryptographic application could be gets operated here. So for 5 times. So why it could be taken 5 times in the sense 5 into 2048 will be 10 kilobytes, something like that. Okay. So finally, each and every, if you are supposed to talking something about the public cryptography or private key cryptography, your block size will be very less. Your block size will be very, very tiny when compared to, so this hash. For let us go ahead and study something about this one, then how this could be evaluated here. So we have studied some asymmetric algorithms such as RSA and discrete algorithms, so that is Raven systems and all those things. Diffie-Hellman algorithm, all these things have been studied by us so far. So this will be taken very limited length of so plain text size. That is 2048 bits of data will be taken as one particular block, and RSA could be gets operated on this 2048. Okay. Just now I have told you 10 kilobytes will be there with you. You have to run that particular user's plain text. You have to run for 5 times, and 5 cryptographic, I mean ciphertext text is going to be generated for your actual data of 10 kilobytes. Okay. So that is the one more problem. And if a plain text will be having some X, and how this could be gets operated. Look at this. So X will be divided into a certain block. Let me consider 2048 bits, and then it could be taken. It could be identified some signature by using a private key or public key here, whatever the so mechanism it might be. You could identify some thing, and you have to get one ciphertext, that is S1, and followed by for second block also you may be perform same thing, and for third also you have to perform same thing, and fourth also you have to perform same thing, and n also, I mean nth block also you have to perform same thing. So here you could consider, so your block size will be n blocks will be there. You may be generate so n different kinds of ciphertext here, n different kinds of ciphertext, while applying for decryption. So again, so the recipient will be gets operated this particular RSA in decryption mode. So for S1, he maybe gets operate one decryption algorithm. Same decryption algorithm can be done by so S2, S3, and Sn. After getting everything, he must be append that particular total decrypted algorithms outputs, and he maybe get rid of get rid of everything here. So this could be gets happen. So if you perform this kind of operation here, what exactly the problems will be raised? Problem number one, high computational load. Because already we have seen it could be operated on a discrete logarithm problem, otherwise the number system. So applying of a discrete logarithm or number system by using prime numbers, it will be take huge computational load. Okay, for doing the same kind of encryption and decryption operation on x1, which could be yields as s1, x2, which could be yields so s2, x3, which could be yields s3, so and so on and so forth. So many number of blocks will be there. Each block will be calculated with huge number manipulations, integer manipulations. So it could be takes huge computational load on the system. This is the first and foremost, problem which could be raises for doing this particular kind of business. And secondly, message overhead. Message overhead in the sense, if your message will be huge amount of message will be there. For example, one gigabyte will be there with you. So you have to perform same kind of operation for several number of times. Since your block size of RSA, your block size of Diffie-Hellman, your block size of Raven will be very less. Okay, block size will be very less. So that the message overhead will be continuously gets occur. And then third one is security limitations. Security limitations in the sense, if persons will be gets identifies. So if person will be gets identifies what is the exact key for this particular S1, obviously everything will be gets identified. Of course, it is not that much easy, but there is a particular probability to get the key also here. So that is the specification you need to understand. Three different kinds of problems will be gets occurred while talking about this asymmetric algorithms in terms of doing or with respect to doing this digital signature scheme here. So here you need to understand one specific point here. I'm repeating the same. You need to understand one particular point. If you want to consider, so the plain text must be converted into ciphertext, and ciphertext is only being transmitted. This plain text could not be known to the intruder or any other person other than the recipient. So then you need to, there is no way you need to follow symmetric or asymmetric algorithms. Okay, your intention is plain text must be, scrambled, and the scrambled message must be forwarded to the recipient, and recipient must be operate decryption again, and he will get the plain text back. If situation could be seen in such a way, then there is no alternate to you, so that you have to follow either asymmetric or a symmetric algorithm. There is no alternate for you. And the case number 2, this is the first case where exactly we have to consider. Case number 2 will be, so plain text will be seen by many people. There is no problem at all. For example, your certificates. For example, your land documents. For example, your account details. So something like that. So they may be seen by many people. There is no problem at all. Your certificate, your 10th class certificate. So if you are supposed to submit your 10th class certificate somewhere else, so all the people who are responsible to take that particular certificate will be see that particular 10th class certificate. There is no problem at all. But so the receiver will be identifies whether it is genuine certificate or not. Okay, message will be seen by many people. There is no problem at all. Perhaps that must be taken by many people, but they have to identify whether your plain text, otherwise the document which we have to submitted is authenticated or not. If you want to know this authentication and reliability, then you have to go ahead with digital signatures. Okay, digital signatures will be comes into picture in that particular position. Otherwise, so wanted to scramble the message and have to send that particular scrambled message to the people, then there is no way. You have to follow either asymmetric or symmetric algorithms. Okay, there is no other way. Okay, you have to do such kind of things here. So here, basically, this digital signature scheme will be gets operated on only the documents which could be seen by many people. Okay, however, you need to understand these two, the difference between these two here. Okay, you need to understand the difference between these two. If a text will be plain text, whatever the message you wanted to send it to your friend, that must be scrambled in the sense you have to follow asymmetric or symmetric algorithms. The data which we have to show to everybody, data will be open for all, and need to identify whatever the submitted data by you that will be genuine or not. If you want to identify that one, you need to go ahead with the digital signatures. That is the difference between these two. Then, so here we do have huge amount of computational load will be there, huge amount of message overhead will be there, security will be having some kind of problems are there here. Elimination of all these things, we just introduce one particular algorithm, that is hash functions. What exactly it could be done? So hash functions will be, performance of hash functions will be very, very, very high. Okay, it is also very much secured. If you change anything in the output of hash function, so you may be identify that yes, it is forged. Okay, yes, it is forged. You could consider huge amount of data, huge amount in the sense in arbitrary length. Length will be so very huge, 1 megabyte, 1 gigabyte, whatever the length it might be, that doesn't matter. It could be sent through hash function, will be prepared a very small short message or short signature. Okay, considering that your driving license, let us consider your driving license. Driving license does have a huge amount of data, your name, address, XYZ, many number of things will be there. But providing, so the driving license will be genuine or not, so they just provide one small QR code. That QR code is very, very, very tiny and little enough. Okay, it is very, very tiny and little enough. So if you read that particular QR code by using QR code readers, obviously you have identified that whether it is so genuine or something like that. Okay. Then followed by a solution of this particular kind of things will be hash functions. How hash functions will be seen that hash functions will be gets communicated or prepared. Hash function in the sense, simply speaking, it is a fingerprint actually. Fingerprint in the sense, don't consider your actual fingerprint. So the name of that particular operation is called as fingerprint. Okay, fingerprint of a message will be identified something like this. So your data will be x1, x2, x3, how much of data you have with you. So whole data will be taken into consideration and it could be sent through one hash function. So this after getting this hash value, then we have to operate the signature by using private key or public key. You may be gets operated with the private key or public key. Then you may be get an output that is the signature. Just send this particular signature to the people. Okay. If the signature will be read by them, obviously they will identify whether your document is genuine or not. Okay. So this is what we did previously. So for x1 we have identified one ciphertext. For x2 another ciphertext. For x3 another ciphertext, and so on and so forth. N number of blocks are there. N number of ciphertext will be gets generated. But here, as far as this particular point, so how much the size will be? It might be any length. The length might be anything here. You just operate with so a particular hash function, and after getting this hash value is very, very small enough. So it might be having so 16 bytes in length, not more than that. 16 bytes in length. Nowadays 16 bytes also very small enough. Nowadays people are introduced 128 bytes. For security reasons they have introduced 128 bytes have taken. So the size of whatever the input size it may be, input size will be anything, 1 gigabyte, 2 gigabyte, or 1 terabyte, whatever the size it may be. Size doesn't matter here. But your hash value, after taking this one, sending this particular whole data, whole input to hash function will be generate 128 bit length of code. And on that particular code, using your private key or public key, if you are supposed to follow, so what is that, public key cryptography, you have to use here public key. Otherwise private key in the sense, yes, private key can be used. Okay, using that particular private key on 128 bit, you have been so apply that particular operation, and you could get so 128 bit scrambled message, and this could be considered as the output of your so total thing here. After receiving this one, so here you may be sent. I'll show you how the process will be, protocol will be. Just wait for a while. After getting this particular scrambling, you need to send both information. That is, your actual plain text will be sent to the recipient, as well your S also be sent to the recipient. Okay, whomever the receiver, you need to send these two. Okay, then intruder could also be received this X, I mean plain text, and this yes also, the scrambled message or hash value or fingerprint also be received. He may be X might be able to change from X prime. Okay, X might be changed from X to X prime. He may be made some kind of changes on X, will be results you X prime, and he could not change this S value because it is actually the output of hashing. It could not be changed. So he must be identify so hash prime of so X prime, so that he may be get S prime. Okay, he may be get S prime. So where this S prime and S could not be gets equal. These are not same. These are not same. So okay. So in this way you need to identify. So in this way it has been taken into consideration. Look at this. So protocol of hashing could be done something like this. Alice and Bob are doing their business something like this. Bob has been prepared, so his private key and So private key of Bob and public key of Bob. And there are algorithms to prepare this private key and public key. This public key can be sent to the Alice. Afterwards, so Bob must be considered some plain text, whatever the plain text it might be. And based on that, he must be identified, he must be calculated. So hash of that particular plain text, which will be capital Z. And after taking this particular capital Z, he must find the signature by using SIG of K private key. So PB in the sense private key of Bob here. Private key can be gets identified. So written here somewhat wrong here. Let me write in a proper way. That is K of PB. P in the sense private key, U in the sense public key. Okay. So private key can be operated on hash value. Then he must get some output that is yes here. Now Bob is being communicated. So this X and S to Alice. What exactly Alice will be done at this moment? Alice will be received plain text and signature also. These two, so as well received by Alice. And what exactly Alice could be do here in the sense, Alice cannot modify this S value because it is highly impossible to modify so S value because S value is so signature of hash function. This signature has been, hash function will becomes from h of x. So therefore, it is highly impossible to change this one. If you change this one, your entire crypto system will be gets damaged. And instead of that, what she could do here is, so she will be calculate Z prime. Z prime will be equal to, yes, already some plain text also be there with Alice because it has been sent by the Bob to so Alice also. So she calculated Z prime equal to so h of x, and then she verifies that whether Z prime and S will be same or not. If both will be get same, this verification could be done by public key of the Bob. Public key of Bob, it has been verified. If S and Z prime will be same, yes, whatever the plain text you have received, that is genuine. If S and Z prime is not same, that is it could be written false, then whatever they received plain text, that could be so false. It is not genuine. You can discard and go for one more time and ask to Bob to transmit one more time. This is the protocol where exactly it could be gets happened here. Okay, and based on this particular protocol, so we will identify whether the received document is proper or not. So I believe that many of you have received what you call some Aadhaar cards, and the original Aadhaar card will be kept in our home, and you maybe get what is it? Color Xerox of that Aadhaar card, and you have to make lamination out there. So just you have made some color Xerox. There is no faults in that making color Xerox. But if you change anything before going to take the color Xerox, then that could be somewhat fraud. Okay, if they will be read that QR code from the particular color Xerox, they would not find the same number and the name of that particular person who are appear or there. So then that could be somewhat problem here. Okay, not only color Xerox. Some people have taken some certificates, and the people will be make some kind of changes in certificates, and they have submitted to many places. If they would read that particular QR code from the certificate, and they would identify whether the certificate will be belongs to the person who is quoted over there, it is very easy to identify. Something like that. Something like this kind of operations will be done by using these digital signatures. Okay. And tomorrow we will see so secured hash value SHA-1. We will come across this particular very important kind of algorithm you have in our final examinations. So as per Pramod already told that examinations will not be conducted for us, sir. Okay, no problem. Something like that he told. However, So if examinations will be conducted, this question will be comes to you for 16 marks in our final examinations. It's very simple, pretty much simple kind of explanation by tomorrow. Let us see this particular thing by tomorrow. Then sharp followed by I don't know whether MD message digest MD5 will be there with you or not. I have to check out your syllabus one more time. If it is there, next Dadan class will be MD5. If it is there, okay. Dadan. This is tomorrow's class. This is a day after tomorrow's class. Okay, both will be gets completed in this week. Then after this one, we'll go ahead with key management. For key management, one or two very important algorithms are there. Kerberos algorithm is there, very important algorithm. After taking Kerberos algorithm, so this whole unit number 4 will be gets completed. Okay, that is what today's class will be. 8 members have attended today. Okay, we'll see. Okay, that is what the today's class.